Hello students, today we are going to discuss the relative reactivity of alkyl halides towards SN2 mechanism. So, our topic is relative reactivity of alkyl halides towards SN2 mechanism. See here, as we know in SN2 mechanism, the nucleophile attacks the substrate molecule from the trans side to the leaving group. So, therefore, here the reactivity of alkyl halide towards SN2 mechanism, this depends over ease of nucleophilic attack from trans side to leaving group. Means the alkyl halide in which the attack of the nucleophile from the trans side to the leaving group may occur more easily is going to react more readily. Is it clear? See, we will explain this one on the basis of steric effect. See, here let our alkyl halides are, one is CS3Br, another one is CS3CH2 and Br. This one here carbon is not linked with any carbon. That's why this one is methyl bromide. Here the carbon which has formed bond with the halogen is primary carbon because it has formed bond with the one carbon. So this one is primary alkyl halide. In this case, this carbon is secondary because it has formed bond with the two carbons. So this one is your secondary alkyl halide. And in this case, the carbon which has formed bond with the halogen atoms has formed bond with the three carbons. So it means this carbon is tertiary. Therefore, this alkyl halide is example of tertiary alkyl halide. See, this one is the central carbon here. At this carbon, there is an one Br atom, this one, which is our, this one. Br is our leaving group. As we know, the halogens are good leaving group. And at this carbon, there are three hydrogen atoms. In this case, here at the central carbon, there is one Br and there are two hydrogens and one bulky alkyl group is here. In this case, there is a carbon and at this carbon there are two bulky alkyl groups and there's one hydrogen. In case of tertiary alkyl halide, at the carbon which is linked with the halogen, there are three bulky alkyl groups. In these all, the halogen atom is a leaving group. And now the nucleophile, let our nucleophile is OH minus. So this has to attack the substrate molecule from the trans side to the leaving group. Means here this one is our nucleophile, and is going to attack from the trans side to the leaving group, to the Br, from opposite side to the Br. See, it is clearly observed here. When we are moving from methyl bromide to tertiary alkyl halide, the hindrance is continuously increasing as the size of alkyl group is increasing. So these they will hinder the attack of the nucleophile. So we may conclude that in this direction the reactivity of alkyl halide towards SN2 reactions. As we know, in SN2 mechanism, the reactivity depends over the ease of nucleophilic attack from the trans side. Means the alkyl halide in which the nucleophile can attack from the trans side to leaving group more easily will react more faster. Here, as the number of alkyl group over carbon is increasing, so the attack of the nucleophile from the back side will be sterically hindered, and that's why the reactivity will be reduced. So reactivity of alkyl halide towards SN1 reaction or SN2 reaction or SN2 mechanism, this decreases with increase in what? Steric hindrance. Increase in steric hindrance by bulky alkyl group. See, in this direction the number as well as the size of the alkyl group is increasing. So they are going to hinder the attack of the nucleophile from the trans side. Is it clear? See, in case suppose the question is the two alkyl halides given are one is CS3Cl, one is CS3Br. And the question is, in both the alkyl group is same, and the question is, out of these two, which one will undergo SN2 reaction more readily? See, here remember that as the halogen atoms, they are good leaving group, and remember that the leaving ability of the halide ions, they follows a trend. See, here the I minus ion is best leaving group. So if you will compare as alkyl group is same in both the halides, alkyl halides. So here the reactivity will depend over the leaving ability of the halide ion, because here the Br minus or bromide ion is better leaving group than the chloride ion. That's why here the CH3Br will react more faster and towards the SN2 reaction. Is it clear?